A warm welcome back to the Flux. So in this video, continuing with my last, continuing from my last video on GATE 2024 electrical engineering solutions. In this video, I am going to discuss GATE 2024 electrical engineering power electronic solutions in detail in this series of GATE QIQ solutions. So please stay tuned and watch till the very end. So starting with power electronics, 7 questions came from power electronics. 7 क्वेश्चन आए थे पावर इलेक्ट्रॉनिक्स से, 3 1 मार्क के और 2 और 4 2 मार्क्स के, तो कुल मिला के 11 मार्क्स का पावर इलेक्ट्रॉनिक्स क्वेश्चन आए। हम लोग इस वीडियो में 7 क्वेश्चन डिस्कस करेंगे, एक के बाद एक। पहले एक क्वेश्चन स्टार्ट करेंगे, तो प्लीज़ बने रहिए आखिर तक, और क्योंकि आपको पूरा डिटेल सोल्यूशन मिलेगा इसमें, शायद ही आपको कहीं और मिले। तो चलिए शुरू करते हैं पहले क्वेश्चन के साथ पावर इलेक्ट्रॉनिक्स में, जो GATE 2024 इलेक्ट्रिकल इंजीनियरिंग में आया था ई पेपर में। वो है क्वेश्चन नंबर 27, विच इज एज फॉलोज, जो कि कुछ इस प्रकार है। क्वेश्चन नंबर 27, क्वेश्चन नंबर 27 है, इट्स गिवन दैट इट्स अ 1 मार्क MCQ question. It's given that the following switching devices have similar power ratings. Then which one of them is the fastest? बहुत ही आसान सवाल है, वेरी सिंपल क्वेश्चन, स्ट्रेट फॉरवर्ड क्वेश्चन, थ्योरेटिकल, एंड द ऑप्शंस गिवन आर A SCR, B GTO, C IGBT and D power MOSFET। ये 4 क्वेश्चन आंसर ये दिया हुआ है, ऑप्शंस दिया हुआ है। बहुत ही आसान है, आप सब लोगों को पता ही होगा ये पहले से, बहुत ही थ्योरेटिकल, बहुत ही बेसिक क्वेश्चन है पावर सेमीकंडक्टर डिवाइसेस के ऊपर। इसका आंसर होगा पावर MOSFEट सिंपली। ठीक है, सिर्फ इसका आंसर ना बताकर थोड़ा सा डिस्कस भी कर लिया जाए। SCR क्या होता है? सेमीकंडक्टर कंट्रोल रेक्टिफायर। ठीक है, इसमें गेट पल्स वगैरह देना पड़ता है। इसका एवरेज जो है स्विचिंग फ्रीक्वेंसी होता है, वो आपका होता है अराउंड 500 हर्ट्ज, इन दिस रेंज। GTO गेट टर्न ऑफ थायरिस्टर, तो टर्न ऑफ करने के लिए एक पल्स देना पड़ता है, तो इसका स्विचिंग फ्रीक्वेंसी तो SCR थोड़ा ज्यादा होता है, slightly higher than SCR, which is 1 kilohertz. Next comes IGBT. IGBT has properties which is, some properties which are advantages, combining the advantages properties of MOSFET and BJT. So IGBT, insulated gate bipolar transistor, has switching frequency of the range of 20 to 30 kilohertz. But power MOSFET, it has the highest switching frequency among semiconductor पावर डिवाइसेस, पावर सेमीकंडक्टर डिवाइसेस। पावर सेमीकंडक्टर डिवाइसेस में से पावर MOSFET का फ्रीक्वेंसी, स्विचिंग फ्रीक्वेंसी सबसे हाई होता है, जो होता है अप्रॉक्स 500 किलोहर्ट्ज टू 1 मेगाहर्ट्ज, जो कि बहुत ही ज़्यादा होता है। इज देयरफॉर यूज्ड इन हाई फ्रीक्वेंसी स्विचिंग, एज यू माइट बी नोइंग। इस आंसर ऑप्शन, इस क्वेश्चन का आंसर पावर MOSFET। और पावर MOSFEट की स्विचिंग फ्रीक्वेंसी क्यों होता है, उसके रीजन थोड़ा सा डिस्कस कर लेते हैं। बिकॉज this is a majority carrier device, right? So it has very less number of minority carriers. What happens due to presence of minority carriers? There is some minority storage charge which is very less in case of power MOSFET. So its reverse recovery time is also very less as compared to the other switching devices. तो क्योंकि इसका रिवर्स रिकवरी टाइम बहुत कम है, माइनॉरिटी चार्ज स्टोरेज कैरियर्स कम होने की वजह से, माइनॉरिटी स्टोरेज कैरियर्स कम क्यों है, क्योंकि मेजॉरिटी कैरियर डिवाइस है ये, तो इसलिए रिवर्स रिकवरी टाइम कम होने की वजह से इसका स्विचिंग फ्रीक्वेंसी बहुत ही ज्यादा है, of the range of 500 kilohertz to 1 megahertz. And so the answer to this question is question number 27 in the master question paper. It's D, power MOSFET. So I hope the explanation is quite clear, and I have also explained the logic behind, theory behind the answer. So hope you have understood. So moving on to the next question. Moving on to the next question. Not wasting time. Pretty simple question. This was 1 marks. So next question, it is also very next consecutive question in the master question paper. Question number 28 in the GATE 2024 Electrical Engineering master question paper, based on single phase triac based AC voltage controllers, as follows. Question number 28. It is given that single phase triac based AC voltage controller what does it do? It feeds a series RL load. Okay, is given the question, and input AC supply is how much? 230 volt, 50 hertz. R is given as 10 ohms and L is given as 18.37 milliamp. So we are required to find the minimum triggering angle of triac to obtain controllable output voltage. Options given are, this is a 1 mark MCQ question again. Options given are A 15 degree, B 30 degree, C 45 degree, and D 60 degree. So let's move to the solution. Solution is pretty simple. An AC single phase triac based voltage control something like this. There are two SCRs connected in anti-parallel. This is the load. This is the source. Then as 30 volt, 50 hertz. Okay. Load is R equal to 10 and L equal to 18.37 milliamps. Minimum, there is a formula for minimum triggering angle. It's pretty simple in this case. Okay. minimum triggering angle formula is given by alpha equal to tan inverse omega L by R. So tan inverse 2 pi into 50 into 18.37 m by 10. So it will be around tan inverse 0.13837 pi. It will nearly equal to tan inverse 1 by root 3. If you calculate on the virtual calculator, this will come nearly equal to 1 by root 3. So it is nearly equal to 30 degree. Very simple. So this is the solution. इसका आंसर आ गया कितना? ऑप्शन डी 30 डिग्रीज. बहुत ही आसानी से. ठीक है. What is this angle? Let us look into theory. I mean the concept behind discussion. What is this alpha basically? Meaning alpha meaning. It is nothing but the impedance angle. Right? Impedance angle is this one. So impedance angle is what? It is the angle by which the current waveform lags the voltage waveform. Now voltage will have a zero crossing at. Voltage will have a zero crossing at like this, t equal to 0 से the sine wave, and current will be lagging it somewhat, some like this it will start due to the inductive effect of the load. Inductance is there. So this is the minimum angle, means alpha mean is this point. Okay. If alpha, when the triggering angle is before this point, say, then the pulse is of actually no use, because the current waveform will anyway start from here. So we are not controlling actually, because alpha will, the firing will have effect, triggering will have effect only if the pulses are applied beyond this point, so that we can control the current. I mean the switching, I mean the turning on, or the commutation of one thyristor and the switching on of the other thyristor, like that. That will happen only if alpha is applied beyond this point. If it is applied before this point, then this pulse will have no effect, because the circuit will automatically get turned on after this impedance angle, alpha mean equal to theta. So alpha mean equal to theta, this is the impedance angle. If it is turned on beyond theta, then only this pulse will have effect, because the current can control the switching, I mean the current in the circuit. If it is applied beyond this point, then we cannot control the current in the circuit. The current will automatically start at this impedance angle when omega t equal to theta, right? If the pulse is applied before this point, before this time instant. But if alpha is applied at least at this or beyond this time instant, then we can control the current. Current waveform is this and voltage waveform is this. So the minimum value of alpha, the firing angle of the thyristors in the triac connecting anti-parallel single phase triac, should be alpha mean equal to theta, equal to the impedance angle of the load. So answer to this question is 30 dB, and I will explain the theory of the concept behind it also. Hope it helps. If you have not understood, you can ask in comments. So that's it for this question. Let's move on to the next question. This is also a simple 1 mark question, MCQ, based on a very fundamental concept. Okay. So let's move on to the next question. So next question is based on force commutated thyristorized step down chopper. This is quite an unconventional question. मुझे लगता है ये थोड़ा सा अलग तरह क्वेश्चन है. 30 क्वेश्चन में 35 मास्टर क्वेश्चन पेपर में ये क्वेश्चन हम लोग जनरली नहीं देखते इस तरह क्वेश्चन. मतलब हम लोग ये इस तरह चॉपर पे ज़्यादा नहीं उतना पढ़ते हैं, इसलिए थोड़ा सा ये अलग हो गया. चलिए क्वेश्चन को शुरू किया जाए, डिस्कस किया जाए, चर्चा किया जाए इस पर. क्वेश्चन नंबर 35 इन द मास्टर क्वेश्चन पेपर इज एज फॉलोज. Force commutated is given. Force commutated thyristorized step down chopper. You can write the exact words. Given the question. Thyristorized step down chopper. This is given the question. Neglect on state voltage drop across the power devices. Capacitor is initially charged. Degrees as the polarity given, and load current IL assumed to be constant at 10 ampere, and initially THM thyristor is on, THA is off. Okay, and is you going to find the turn off time available. Turn off time available to THM in microseconds. In microseconds when THA is triggered. To 3 decimals, I think. Whatever, it doesn't matter. 2 decimal something. So chopper circuit is given somewhat like this. This is the main thyristor THM. Parallel L is connected, and this is connected. There is a capacitor here. 10 microfarad. And load is connected. Here there is THA. And this load is connected here. Parallel is connected. Load is connected. Constant current load. Running 10 amperes. Okay. This is 50 volts. So the question is pretty simple. It is equal to find the time available, turn off time available to this thyristor THM after THA is switched on. So let's analyze what will happen after THA is switched on, and when the instant will come when THM will get switched off, so that THA will carry all the load current. The load current here is constant at 10 amperes. Okay. So when initially this was THM was on and THA is off. So THM is carrying all the load current, that is 10 amperes initially. Now once THA is switched on, some part of the load current will flow through THA and flow towards the load. It will get distributed among THM and THA. Okay. So the current through THM plus current through THA will be 10 amperes. Now this capacitor initially charged to 50 volts in this polarity will get gradually discharged. Charged in the opposite direction, such that an instant will come when this thyristor M will stop conducting, it turned off, and all the load current will be carried through thyristor A. and at that instant, as you can see, when this is turned on, constant current. The load is not changing, current is, so the load is also not changing. So voltage to the load is also constant, 10 ampere into the load impedance. And when this is conducting initially, this is short. So this voltage gets carried through this point to the load. So effective voltage across the constant current load is also 50 volts, right? So finally also, as the current drawn will be the same, load has not changed. So the final voltage also through the constant current load will also 50 volt, and at that instant this will have stopped conducting, and the entire current will be conducted by THA. Okay. So the capacitor will also get short at that time, because to have 50 volts across here, this branch must be short. This is already short when it is conducting, so this voltage should also be 0. So initially this VC0 we know, with the polarity it is given as 50, and let's say turn off time is T off. Okay, turn off time. Turn off time or PHD. At this instant, what will happen? The voltage across the capacitor will be 0. Okay, and the current through the capacitor will be how much? Current with this polarity, it should be flow in this direction. That is, this direction is positive. So when the entire current is carried by THA, this current, same current will flow to the capacitor, and this will be the load current. So IC turn off will be how much? This is at turn off time. This is IL T off will be how much? Minus IL will be minus 10, because all the current will flow through the thyristor A to the capacitor to the load. So this will be minus, and VC delta VC will be what? VC T off minus VC 0. 0 minus 50. 0 minus 50 equal to minus 50 volt. Now we can apply the equation for voltage and current and capacitor at T off, T equal to T off. At T equal to T off, what will happen? IC T off equal to C delta VC by T off. You can write this. Okay. IC T off is what? Minus IL, so minus 10. So minus 10 equal to capacitance is given as 10 microfarad, 10 mu. Delta V is how much? Minus 50. What do we need to find? T off. From this equation, what we can do? We simplify. So if you take that side, T off simply comes as 50 microseconds. Pretty simple. Simply I will explain the process, how the circuit is working. So the answer to this question is pretty simple, 50. Turn off time available to THA is asking microseconds. So JP comes in microseconds as 50. This is 1 mark and MET type question. Sorry. And pretty simply I have solved it. Explain the process also of how the circuit works and how the turn off time has been derived. So I hope it helps and it's clear for the viewers. So if you have any queries, you can ask in comments. That's all for this question. Let's move on to the next question. First, without wasting any time. The next question, moving on to the next question. Question number 62, 2 marks in the master question paper. There is no single phase half controlled bridge converter. Okay. Question is as follows. Question number 62 in master question paper. Given single phase, writing the question is given half controlled bridge converter supplies an inductive load with ripple free load current triggering angle converter given as 60 degrees. Okay. So we are required to find ratio of RMS value of the fundamental component, of the input current to the RMS value of the total input current. This is a numerical answer type question of 2 marks. Single phase half controlled rectifier, half controlled converter. Let's draw it. Something like this. This will be here. This will be here. Okay, so there are 2 thyristors and 2 diodes. So T1, T2 and D1, D2. This is the load. Okay, inductive load, ripple free, highly inductive. So constant say current. IL. So let's draw the current waveform for the source side. Okay. Say IS is constant. Now what will happen? This load current will be supplied by the source only after the thyristors are triggered, the positive half cycle, negative half cycle. So let's draw the source current waveform. It will be something like this. Load current waveform is this, simply IA. Source current waveform will be on what? Let's side by side. It will be like this. This is theta omega t, this is theta c. IL, this is IS, this will be IL, this will be 0 degree, this will be 60 degree, 180 degree, 40 degree, 360 degree. And it repeats. During 0 to 360 degree, this will free wheel across this loop, so that there will be no current drawn from the source. Okay, and when the thyristor is triggered, then this source will deliver current to the load, and the source current will equal to the load current for 60 degree to 180 degree. Similarly, after interval 180 to 240 degree, the current will free wheel load conduct free wheel, and after this T2 is triggered, then it will conduct through this like this. Okay, so the load current will be opposite. The source current will be opposite of the load current, minus IL. This IL is constant. Okay, so the RMS value of the fundamental component of the input current, RMS value of the total input current. Okay, total input current RMS values will be what? IS RMS will be simply from the integration, from the definition of RMS value, we can write IL square d theta. Okay, and as this is symmetric, we can write 0 to 2 pi IS square, 0 to 2 pi square root. This is symmetric, so what we can write? This conducts for 62 material. This is 2/3 of the entire waveform, entire cycle. 2/3 and 2/3 here. So this will be what? We can write as square root 2 by 3 times IL, and IS 1 RMS fundamental component RMS value we can write as what? To calculate it, you can write it as what? 1 by 2 pi we have to calculate by Fourier series. Actually, Fourier series fundamental component RMS will come later. Fundamental maximum we can find out maximum values. Maximum values will be what? IS1m will be given by 2 by 2 pi 2 by 2 pi this we can write, this we can correlate with this kind of waveform, sine waveform shifted by 30 degrees, because it will be symmetry with respect to 30 degrees. See, 210, this is 30, so it will be symmetry with respect to 30 degrees. So we can calculate in that way, that fashion. Like we can write IL sin theta minus 30 degrees. Fundamental component. So there is no n theta, there is no n theta, and is this symmetric by 30 degrees? By shifting 30 degrees, about 30 degrees is symmetry, you can see. So we have also shifted sine of angle by 30 degrees. So we can integrate it from what? 0 to pi, but actually the basic value will be what? From 60 to 180. That is 60 to 180 means pi by 3 to pi, and it will be similar in the second negative half cycle also, right? So we can write it 2 into multiply 2. So integrate this, it will be cos, 1 pi will get cancelled, so 2 by pi IL, okay, minus cos theta minus 30 degrees, and it will be pi by 3 to pi. So putting pi by 3, you will get, first putting pi, apart from pi by 3 is minus sign, you will absorb that. Pi by 3 means 60 degrees, 60 degrees means 30 degrees means cos 30 is root 3 by 2, and putting pi you will get 150 degrees, cos 150 degrees minus cos 30 degrees, so it's 2 cos 30 degrees. So 2 cos 30 is what? Root 3, so 2 root 3 IL by pi. This is the maximum value minded. So what will be the RMS value? S1 RMS will be root 1 by root 2 times of this, so 2 by root 2 gives root 2, so root 2 into root 3 gives root 6. So it will be root 6 by pi into IL. Now if you take the ratio of IS RMS and IS1 RMS, IS1 RMS, IS1 RMS by IS RMS, you will get what? Root 6 by pi IL upon root of 2 by 3 IL. Okay, so simplifying this, 3 will go up, so this will be basically 3 by pi. And if you simplify it, you find the value, it comes as 0.955. So it is adds up to 3 decimal places. So 3 decimal places it's 0.955. The derivation I have shown and the operational circuit as well. So I hope it's very clear and easy to understand. I have shown the derivation also for easier understanding. This shifting property is critical here, and it comes handy here. The shifting property to find the fundamental component, maximum value, and from that the RMS value. We have to shift the sine waveform by 30 degrees. It is symmetrical about 30 degrees. By shifting the sine waveform 30 degrees, as you can see. So here, in this way we have found. So the answer we have found here is by this approach 0.955. Okay, 3 by pi. So that's the detailed solution extension. I hope it's clear. If you have any doubts, you must be comments. Please check the solution and the steps once. I hope it will be clear. Moving on to the next question. Alright. Okay, so moving on to the next question. Question number 63 in the master question paper. 2 marks and 80 question as follows. It's based on single phase full bridge voltage source inverter. So it's given single phase full bridge voltage source inverter VSI feeds a purely inductive load inverter output voltage waveform is in 180 degree conduction mode. Square wave. Inverter output voltage square wave one-degree conduction mode. Pretty simple question actually. 2 marks. Let's put in. Fundamental frequency of the output voltage is 50 Hz. Okay, that's fine. Frequency is 50 Hz, fundamental frequency, and the voltage source is 100 volt, and inductance, load inductance is given as 20 millihenry. Okay, so peak to peak current, load current is asked in amperes. Unity question of 2 marks. Question is pretty simple. Let's draw the circuit for a single phase full bridge voltage source inverter. Something like this. Okay, so 100 volt yes, and load is given as purely inductive, quantitative conduction mode. Okay, 20 millihenry. F naught is given as fundamental frequency of 50 hertz. Okay, and these are the values given. So let's draw the waveform for the load voltage and the load current. Load voltage waveform is pretty simple. In quantitative conduction mode, it will be a square wave, something like this. This is 100 volt. This is minus 100 volt. 50 hertz means 20 milliseconds. 1 by 50. So this will be 1 by 50 by 2. This is 1 by 100. So this is 10 milliseconds. This is 20 milliseconds, and so on. Load current will be what? Integrate this voltage according to the relation V equal to L di dt. So I equal to 1 by L integration v dt. Right? Integrating a square waveform will give you a triangular waveform, something like this. You have to find this delta IL basically. So delta IL will be given by simply by this formula as what? 1 by L, that is 20 millihenry, integration of V dt, that is you have to integrate 100 volt for 1 by 100 seconds, that is 10 milliseconds. 10 milliseconds. Milli gets cancelled, 10 gets cancelled. So it is basically 15 hertz. Pretty simple. The answer to this question is 15 hertz. Pretty simple. This student have been asked for 2 marks. Student has given 1 marks. Anyway, they have given marks quite easily this one. In some of the questions like this one. So answer to this question is pretty simple. Simply 50 amperes. Very basic single phase full bridge voltage sourcing model concept. If you apply, if you know for a purely inductive law, the answer comes up to very simply 50 ampere, as you can see, and very explained with proper circuit diagram and waveforms, with calculation and derivation data. So any doubts still, you can ask in the comments. I hope this question, the solution to this question is clear. So let's move on to the next question without delaying any further. This is as follows. Next question, question number 64 in the master question paper. Okay, 2024 electrical engineering power system, power electronics. Sorry. This is as follows. There is no DC-DC converter. Actually, boost operator. Boost converter. DC-DC converter. Okay. Current through inductor is continuous. Is continuous. Switching frequency is given as 500 Hz. Okay. Load voltage across the load is going to be constant. Voltage VO across load constant. Okay. And ripple free. So peak inductor current is to be given. In amperes. Nearest integer. The DC-DC converter, boost converter is given as 20 volts. This is inductance of 2 millihenry, and the switch is given like this. This is a diode. Capacitor is given 40 volt inputs constant voltage. This is load current is given as, it's not given, load resistance is given as 10 ohms I0. This is I. To find the average value of the load inductor current, solution with 2 marks. NET question, but simple only. Average value of inductor current can be given by voltage conservation, power conservation as V in into IL average equal to V0 into I0. V0 and I0 is what? V0 by R. We can also write V0 square by R 0. So V in is 20, IL average we have to find out, and V0 square is given as 40, R0 is given as 10. So you simplify this, you will get 160. So IL average is what? 160 by 20, that is 8 amperes. This is the average component or average value of inductor current. But we need to find the peak value of inductor current. How will we find the peak value? We have to find the rippling current when this switch is closed. When the switch is closed, what will happen? This will charge to this. Okay. So the switch will be closed. To define the duty cycle will be given by what? This is a boost converter. The output voltage V is given by V in by 1 minus D. So 40 equal to 20 by 1 minus D. So 1 minus D equal to 20 by 40. So half. So D equal to 0.5. D is 0.5. Okay. So current ripple will be given by what? In this, when the switch is closed, V in equal to L delta IL by D T. So T is nothing but 1 by Fs. Converting that, delta IL will be what? D V in T here. So the numerator gets F to L. So D is 0.5, V in is 20, F is what? 500 Hertz, and L is what? 2 milli Henry. 500 2 is 1000 milliamps, so this will cancel. So what we can write here? Right? So check. Yeah. So this will be nothing but I think 5 amperes something. Sorry, 10 amperes. 10 amperes. Yeah. So the peak inductor current will be given by what? IL peak is nothing but IL average. Average current that will supply inductor plus the peak current, half of that. So delta IL by 2. So IL average is what? Calculate 8. Delta IL is what? 10. By 2 is 5. So 8 plus 5 will give you 13 amperes. So answer to this question is pretty simply 13 amperes. And I have written the process as well as circuit. Then steps, everything discussed. Okay. Hope it is clear. Finding IL average by power conservation, you would power to output the subject. This is the very last question in the master question paper also. Question number 65. Based on single phase fully controlled thyristor converter bridge used for regenerative braking of separately excited DC motor. So the very last question, question number 65 from master question paper of 824 electrical engineering from power electronics subject, is as follows. then single phase fully controlled high resistor converter bridge used for regenerative braking. Okay, and first separately excited DC motor specifications are given as rated armature voltage 210 volt, armature current rated armature current is 10 amperes, rated speed is 1200 rpm, armature resistance is 1 ohm, input the converter is known as 40 volt triggers. This is the data given. Armature of DC motor is fed from fully controlled control bridge. So fed from control bridge converter. Okay. And field current is constant. For IA to be maintained at rated value, that is 10 ampere, what is the triggering angle alpha of the converter bridge? Regenerative braking. IA to be maintained at rated value. So triggering angle alpha of the converter has been asked. Two different places. Is it a related question of 2 marks? ये डेटा दिया हुआ है, बहुत आसानी सॉल्व कर सकते हैं इसको, देखते सोल्यूशन कैसा होगा, उसी पे होगा. So it is a fully controlled single phase fully controlled high converter bridge, something like this. Motor is motor and field is separately excited. And if this constant is given, this is VA, this voltage, this VA. So at rated conditions, let's find out what will be the back EMF. At rated conditions, back EMF of the motor is given by EB equal to VA minus I into RA. Very simply, तो आसानी से हमको पता है वैसे वैल्यूज पुट करते हैं 210 minus 10 into 1 and use it 200 volt Now, in a separately excited DC motor, what happens? Field current is constant. So, back EMF is directly proportional to only speed. So, at this condition, rated speed is equivalent RPM. So, at 6. Okay, rate is given, operating condition 600 RPM. At 600 RPM, if the armature terminals of motor are suitably reversed for regenerative braking, with IA maintained at rate value, what is the train? So, at rate conditions, the speed is 1200 RPM, and at operating conditions, speed is 600 RPM. So, you can find the back EMF at operating conditions. This is rated as how? Will be rated into n by n rated, very simply, right? So, EB rated is the form of 200. N is given as 600. N rated is given as 1200. So, it will be 100 volt. Simply, very easy. Now, what happens in regenerative braking? In normal operating conditions, if this is the term, VA this replaces where voltage source like this. Normal operating, this is VA, this is IA, this is E. But when regenerative braking happens, the terminals of, the polarity of E is reverses. Direction of current remains the same. During regenerative braking, resultant becomes like this. This is IA, this is VA, this is E. So applying KVL during regenerative braking, in the armature circuit, you can get what? What we can get? VA minus IR equal to EB minus EB. Right. So VA is how much? IRA minus EB. So IRA is maintained at ready condition, rate value 10. RA is fixed 1. EB your formula is 100. So this will be how much? Minus 90 volt. Now for a fully controlled thyristor converter single phase, we know the formula for output voltage is nothing but the armature voltage in this case, because the armature is connected across the output of the bridge. Fully controlled thyristor converter bridge. It's nothing but 2 Vm by cos alpha. Now Vrms is given as 240. So Vm is what? 240 root 2. Okay. And Va required is, the calculator is minus 90. So we put the values here. Minus 90 equal to 2 times root 2 into 240 by pi cos alpha. Now we can simplify. Okay. So from this we get what? Cos alpha equal to how much? Minus 3 pi by 16 minus 9. From this, if you apply cos inverse on both sides, you will get alpha. We are using the virtual calculator that will be in the exam में से virtual calculator करना है. इसको हम पुट कर देंगे बहुत आसानी से. अल्फा का वैल्यू हो जाएगा 22 decimal places as 114.60 degrees. That is only asked alpha का वैल्यू पूछा, ट्रिगर एंगल पूछा कन्वर्टर का, तो वो क्या है? नथिंग बट अल्फा. We found alpha by this approach. First, we have found the vacuum of rate conditions. Next, we have found that in a stability excited DC motor as vacuum is proportional to speed. So we have got voltage vacuum at 600 and equal to operating speed of 600 RPM is 100 volt. Now we have applied the condition for regenerative braking. The IRA minus EB. This is valid for regenerative braking. So from that we have got armature voltage minus 90. Now armature voltage is the output of the which fully controlled phase control which applied the from the output voltage DC value as this. From that we have got what is आज जो क्वेश्चन को पूछा है क्वेश्चन में हम आसानी से मिल जाता है उसका वैल्यू है 114.16 and that is the answer of this question. 90 question of 4 marks on fully controlled phase converter single phase switch. And this was the very last question from power electronics and the last question as well in the entire master question paper of K2 for electrical engineering. So I hope the explanation is clear and it is comprehensive. If you still have any doubts or queries, you can ask in the comment section. I will try to answer. So that's all for this video. Thank you.